Hello. So, we will continue our discussion on cloud computing. Today, we will discuss on a topic which is very much relevant in today's context, that is sensor cloud, right. So, what we have seen or what we are seeing or having these days, it is a world of sensors, right. It is a enormous number, enormous variety of sensors around us, right. It may start from temperature sensor or sensing pressure sensor to atmospheric, different atmospheric parameters, to if you can look at that camera as a sensors. There are other different biological sensors which senses different aspects of our human physiology and other things, right. So, there are different aspects of sensors and it is a ever increasing phenomena, right. So, what we have a set of sensors which senses or accumulates information about environment, about our health condition or about a particular device or so and so forth, and based on the informations. So, there is a at the back end there is some intelligence or decision making systems which take some call and activate, or actuators are activated. So, we have a sensors and set of actuators in the and in between there should be a either physically or logically a decision support system or a intelligence systems which take some things, right. Like if you look at our modern cars, which are a bunch of sensors. Somebody was saying other day that the time is coming where a particular car may have more sensors than mechanical parts, right. It may be a joke, but it says that the amount of prolifications of sensors for monitoring, management and activating different mechanisms and processes around us, right. So, what we try to see that there is a amalgamation, or there is a whether there is a need to integrate the sensors with cloud infrastructure, right, or having a cloud of sensors which has a property of emulating the properties of cloud, right. Like what we have seen, that the different properties of cloud which is making popular, where this type of ubiquitous sensors or a huge volume of huge number of sensors can emulate a sensor cloud which is much more effective than individual sensors, right, that we will try to look at. Again, as we see, that is more of a overview which will open up the scope for you to read more, somebody interested in research activity etc., to look into the things. So, what we see in increasing adaptation of sensing technologies, right, that is RFID, camera, mobile phones are nowadays sensors. So, location, as we have seen that different meteorological parameter are being sensed. So, internet has become a source of real time information. On the other hand, internet has become a real time through blogs, social networks for events happening around us, right. So, two technologies which are extremely pervasive, and it has become a both of them eventually become a part of our day to day life, right. On the other hand, cloud computing has emerged as an attractive solution for dealing with big data revolution, which can able to manage and able to take a call on this type of huge or big volume of data. So, by combining data obtained from sensors with that from the internet, we can potentially create a demand for sources that can be appropriately met by cloud, right. So, what we are trying to look at, that whether we can have this amalgamation of this the technologies or the processes which are collecting data. There is a way of dispersing or dissipating the data, that is accessing the data, So, both sensors, internet, cloud coming together to make a our need or to fulfill the different aspects of our either day to day or commercial or industrial requirements of the things, right. So, rather we have referred a one of the pioneer paper that what next, it is a whether sensor plus cloud is the things which are coming in this particular decade. So, already we know our wireless sensor network. I believe that you have more or less it is known. Just to put some points. So, it is a seamlessly couples physical environment with the digital world. So, it is a what it is there is a wireless sensor networks which has different sensor nodes or modes sometimes we say, which collects information, and those are digitized and pushed through the sync to the central infrastructure. So, it is so what we do that whatever the physical environment is there is being captured and coupled with our digital world. So, sensor nodes are small, low power, low cost and provide multiple functionalities, right. So, typically they are small, they are power hungry, cost wise also not so costly, and has different type of functionalities like sensing capability, sometimes it has a processing capability, memory, communication bandwidth, battery power, and these are the different type of components of the thing. So, sensing and processing at times, or transmitting or store and hold like memory and then push it. So, communication bandwidth and it requires a management of the battery power. In aggregate, sensor nodes are substantially data acquisition and processing capability. So, usually when it used in aggregation mode, they are primarily using acquisition of the data and processing some sort of a processing and push it to the next node or to the sync node. So, useful in many applications, and we know already that environmental, healthcare, education, defense, manufacturing, smartphones and anything where you require some sort of a sensing and monitoring of the things. So, what we see here, there is a battery of sensor node, these are being organized in a particular fashion, but that can be ubiquitously thrown and can reorganize among themselves. There are some gateway with which it connects to the rest of the world, right. And this can be different type of things, like it can be management of forest, plains, city, transport and so on and so forth. So, it finds application in different aspects, like. So, it is either the equipment itself as having a sensor thing, like if I say a car or a airplane. So, those are different sensing units doing it, or they are sensing and sending data like a temperature sensor, moisture sensor, or humidity sensor, say velocity sensor. They basically collect information, send it out, and with all different sensors collected information, a call is taken by the management or the control unit, right. So, there are typical limitations in sensor networks that we already we understand, that is a very challenging to scale sensor network to large sizes. Suddenly scaling up or scaling down this sensor networks is a major challenge, right. So, whatever you have deployed and the physical sensors is there, suddenly instead of collecting a, say I want to increase, I am collecting temperature or acquiring temperature, and suddenly increase it to a larger scale and to want to collect a larger thing, its scaling up is different, even changing the granularity is different, right. So, proprietary vendor specific design in most of the cases, difficult for different sensor networks to be interconnected. So, that is another problem, interoperability. Sensor data cannot be easily shared between different groups of users, because everything, if it is isolated, then it is extremely difficult to share. First of all, there is a problem of the proprietary format. Secondly, there may not be mechanisms to how to share data. So, I have a bunch of sensors collecting and putting somewhere, and another bunch of sensors and putting somewhere, and those need to be talking to each other, right. So, that need to be enforced, right. Insufficient computational and storage resources in sensors to handle large scale applications, right. If I have a more complex application, it is difficult to do on this. used for fixed and specific application that cannot be easily changed once deployed. So, usually the sensor deployment are for fixed and specific applications that cannot be easily changed or deployed. Slow adaptation of large scale sensor network applications. So, if you have a large application, so the immediate deployment and adaptation becomes a challenge. So, these are some of the things which are we see so to say with this type of sensor network, including wireless sensors networks, right. And similarly, if we look at there are in terms of the cloud, other than all the limitations we have looked into, there are other typical limitations like immense power of cloud can only be fully exploited or fully appreciated, so to say, if it is seamlessly integrated with our physical lives, right. So, it is not only that when I demand I take things, that it takes a some sort of a real world situation and process it on a real world things, then only that actual power of the cloud is manifested or appreciated by the community at large. So, what it means that providing a real world information to the cloud in real time and getting cloud to act and serve us instantly, right, that is one thing, or another thing, adding the sensing capability to the cloud. So, cloud as such as the infrastructure wise just waiting and waiting for something to use it, rather than it has coupled with the sensing capability which sense, do some processing and react to the things, right. So, having this sort of sensing capability will give a definitely a extra edge to this sort of a cloud computing. So, so to say it is if not if we do not want to tell is a limitation of cloud, but to make it cloud really useful and effective, we need to do this, right. And so, one side we have sensor networks. So, typically we know that there is a bunch of sensors, there is a way, there is a sync node or gateway through which it is connected to the rest of the world, and this there are different way of looking at the this sensing things, like they can follow a particular path to the sync, or they can form different clusters, make the cluster head and so on and so forth. There are technologies what you can see in the sensor network. Or on the other side, if you look at the cloud infrastructure, we have different sort of things, like there are cloud server, cloud computing platforms, several cloud level applications, mobile computing, cloud security aspects, economics and so on and so forth, like, and different models and different level of manifestations are there. So, there is a missing link which you want to connect, like making this sensor overall as a sensor cloud, or connecting with the rest of the things which the cloud support, which exactly the sensor cloud infrastructure or sensor cloud network try to address. Like so, like if we look at say a typical scenario, like this sort of things, where there are multiple parties, multiple information are being exchanged, this different type of resources are being different type of equipments, especially most cases our mobile phones are used to capture this information, right. And if we look at the cell phone is somewhat omnipresent and records the tourist gesture, activities, applications such as in camera, microphone etc., which could have been captured. Cell phone produces very swift responses to real time after the processing geographical data to show that if it is interfaced with the geo cloud type of things, acquiring tourist physiological data and wearable physiological sensors, physiological sensors like blood, sugar etc., and cross comparing with the medical records, right. So, if somebody needs some medical help, this can be automatically initiated or before the something serious happens. There are speech recognition system to find out things, image processing of the some restaurant logo or accessing internet based things, accessing tourist social network profiles to find out his friends etc. So, what we see that even though it is a simple scenario of visiting a particular place, but there are several type of sensors at different levels which are there. Some are the physically doing that, some are maybe doing some derived informations, right. So, it is according like whatever been posted in the social network, finding the friends, etc. It is also trying to do some derived information and try to coupled with this physical information, its location, if as at all we are trying to do monitor its other type of infrastructure, those type of things are being used to that type of things. So, the fact the cell phone cannot perform all the tasks which is needed, right, that we see that the cell phone cannot perform. So, we need require some of the something which is required for which is something more than this, or coupling sensors with cloud philosophy. So, there is a need to integrate sensors with cloud, right. The acquisition of data feeds from numerous body area networks, right, like different type of body parameters, and wide area like water quality monitoring. That is a small or large scale things what we need to do, that sensor networks in a real time type of things. So, what we need to do, that it is not only real time informations, but also real time processing of the informations is a requirement which is coming up, where sensors integrating as sensors with cloud may give some results. Real time processing of heterogeneous data sources in order to make critical decision, right. So, we need to do some real time processing of heterogeneous data sources coming from different type of sensors, like something coming from the body area network, or sensors which are taking more health related data, accompanied by the other type of things like maybe the overall environmental things, along with some of the sensors which gives that like related to the heights and so on and so forth, and try to take a call integrating those data. These are the different heterogeneous sensor informations which need to be integrated. So, automatic formation of workflows and invocation of services in the cloud one after another to carry out complex tasks, highly sweep data processing using immense processing power of the cloud to provide quick response. So, one side we have a capability of wide variety of sensors collecting information, another side what we have that computing power and the ability to interoperate between different type of heterogeneous data from the cloud we want to integrate together. So, it comes to a scenario of what we say sensor cloud. So, what if we try to look at the sensor cloud as an infrastructure that allows truly pervasive computing using sensors as interface between physical and cyber worlds. The data compute clusters as a cyber backbone and internet at the communication media, right. So, let me repeat, it is a infrastructure that allowed pervasive computing using sensors as an interface to the physical and cyber world, right, and data computing clusters at the cyber backbone and the internet as the communication media. So, it is an amalgamation of these different technologies to realize a or to basically support a real time application or real time processing of information, right. So, it integrates large scale sensor network with sensing applications and cloud computing infrastructure. It collects and processes data from various sensor networks, enables large scale data sharing and collaboration among users and applications of cloud, delivers cloud services by sensor rich devices, allows cross disciplinary application that span organizational boundaries, right. It says lot of things, right. So, it says that what we are discussing, that to make it the whole thing ubiquitous and omnipresent and to serve a variety of applications. So, just to reinstate, that enables user to easily collect, access, process, visualize, archive, share and search large amount of sensor data from applications, supports complete sensor data lifecycle from data collection to the decision support system as we are discussing. Vast amount of sensor data can be processed, analyzed and stored using computational and the storage resource of the cloud, right. So, it is as a cloud as by virtue of it that having a huge infinite storage, theoretically I can store this huge volume of data for further processing. So many sensors are sending, it is a really a data challenge or a big data problem. Allows sharing of sensor resources by different users and applications under flexible usage scenario, enables sensor devices to handle specialized processing tasks. So, these are sensing, processing, actuating type of services. So, sensor cloud enables different network spread in huge geographical area to connect together, be employed simultaneously by multiple users on demand, right. So, if you can see that from the sensing technology, we are we are trying to incorporate, or what we are trying to do in the sensor cloud is putting that good properties or goodies of this cloud into this sensing overall sensor network infrastructure. So, you can have a something overall overview of the things. One side this sensor network where there is a sensor network proxy, which proxies it for the rest of the network. This handheld devices or the handheld sensors like mobile phones and other type of things. There is a traditional cloud, we have a sensor cloud proxy which handles it, and there are satellite connections, standalone GPS sensors, there are network of sensors with capabilities, different sort of things are being connected over the internet network. So, sensor cloud proxy, it primarily interface between the sensor resources and the cloud fabric, manages resource network connectivity between the sensor and resources. So, it proxies on behalf of this or this your sensors resources, which can be heterogeneous, which can be homogeneous type of things. So, it handles data format conversion like using technologies like XML, interoperable data cleaning and aggregating, data transfer to the cloud storage, and so on and so forth. Sensor network proxy, for sensor resources that do not have different connection to the cloud, this acts as a proxy. So, it is unlike, it is not it cannot be expected that all sensor network will have that connection to the cloud and able to interface to the cloud. So, that is why we have a proxy by which it is connected to the cloud, right. There are different other use cases, like one is that traffic, we can say that traffic flow sensors that deploy large number in cities, places like large cities, right. These sensors are mounted on traffic lights and provide real time traffic flow data, right. So, these are on traffic light systems, on signaling system, they can be mounted and real time things. Driver can use this data for his route planning, right. You see that there are this amalgamation of information and taking a call for somebody from the sensor things is there. In addition, if the traffic flow sensors are augmented with low cost humidity and temperature sensor, that can also provide customized local view of the temperature and heat index on demand, right. So, it is also support the meteorological department, which otherwise have fixed number of sensors, right. So, I can have a rough idea. So, I have that precision sensor of the Met department, which gives more precision, and I have this local sensors which are on that lamp post and traffic signal and lights, which gives me a much more real time scenario of this temperature. So, same type of infrastructure with little augmentation, we can have different layer of information, or in other sense you can see that you have virtualized these things into different type of things, right. I have one side that meteorological departments looking for the met type of things, traffic management department looking for that what is the overall traffic managing things. I can have drivers on the road which uses for route planning and so on and so forth, right. So, we can have one overview of the sensor cloud infrastructure, there are the standard way of looking at it, data processing, routing, power management, clock synchronization, localized for direction, this is which are there physical sensors which has to be there. And I basically what we try to do is having a virtualized scenario or the physical layer over that, as we have seen in the cloud, a virtualized scenario which helps me in looking at different type of user related issues, right. So, I have now a set virtual sensors or virtual sensor groups which can answer to the different category of applications, like as we are discussing, one may be met type of, one may be traffic type of applications, one may be accident management type of things, and something may be overall looking at that other phenomena like how is that lightning or how is that overall environmental situations of the particular place. So, we talk about virtual sensors. What it is, as we have seen, it is an emulation of the physical sensor that obtains its data from the underlying physical sensor, as we have seen virtual machine etc. So, it is emulating the machines from the underlying the physical machines, right. So, virtual sensors provide customized view to the users using distribution and location transparencies, right. In a sensor wireless sensor, this hardware is barely able to run multiple tasks at time and difficult to multiple VMs and as in a traditional cloud. To overcome this problem, virtual sensors acts as an image in the software of the corresponding physical sensors, right. So, that as we have seen that in case of our cloud things also. So, virtual sensors contain metadata about the physical sensors and users currently holding the physical sensors. So, we have a virtual sensors layer. So, there are physical sensors, over that we emulate these virtual sensors, and there are different virtual sensor group which uses that. It may so on happen one physical sensor may be contributing to the physical sensor. So, one to many, many to one, many to many, and this type of things scenario may come up. So, as we are discussing, so there are sensor cloud admin. So, this is a sensor cloud infrastructure which has different physical sensors, have virtual sensor groups which have underlying physical virtual sensors which are coming from the physical sensors, and then we have end users which are more looking for this more inclined to the applications or more bothered about the applications which talk to this uses this sensing network to look at it. So, there is a management of this sensor cloud like registering physical sensors, management manage infrastructure, and that may happen the sensors because the sensors are low powered, managed by different type of in different situations. So, sensors may come up or can go down and type of things. So, the sensor cloud need to be managed appropriately. And the same thing if we look at the client, the portal, it goes for a provisioning, resource management, monitoring, virtual sensor group, physical sensor groups, and so forth. This overall architecture if we look at in other way, it's so client request to a particular portal servers which in turn go for that process the query. It needs to look at the different virtual sensors which can answer to the queries, and which in turn look for the physical sensors and so on and so forth. So, as we have discussed there are virtual sensor configuration, it can be one to many, many to one, many to many, and can be derived, right. So, there are several scenario, many to many, one to many, then we have this derived type of scenarios. So, in case of a many to one to many, in this configuration one physical sensor corresponding to many virtual sensors. Although individual sensors own their virtual images, the underlying physical sensor is shared among all the virtual sensor accessing it, right. So, it is the middleware which computes the physical sensor sampling, duration, frequency by taking into account all the users, it re-evaluates and duration. So, it is basically the synchronization is ensured by this underlying middleware and type of things. So, it is a where we have one physical sensors corresponding to more than one virtual sensors. Many to one, in this configuration geographical area is divided into regions. Each region have one or more physical sensor and the sensor network. When a user requires aggregate data of specific phenomena from a region, all underlying WSNs or wireless sensor networks switch on with the respective phenomena enabled, and the user can access the aggregated data. So, here what we have a large geographical space which is divided into regions, and each has separate wireless sensor network, and if there is aggregated some processing is required, then these are switched on and give a aggregated view on the things, right. So, it is a scenario of many to one. We can have as a many to a combination of one to and many to one type of scenarios. there is a special scenario which is derived. So, it is a derived configuration refers to a versatile configuration of virtual sensor derived from a combination of multiple physical sensors, right. So, there are virtual sensors which is a combination of the derived sensors, like here you say there is a proximity sensor, light sensors, there are say habitat monitor, temperature, humidity sensor, and these are integrated into to take a call, right. So, this configuration can be seen as a generation of other three configuration, generalization, basically generalization of the other three configuration lies in the type of physical sensors with a physical sensor communicate. So, it emulates a sensors looking at different other physical sensors. So, it derived a sensing capability from the other physical sensors, right. So, this type of scenarios are being emulated. So, there can be many different kind of physical sensor that can help a complex question. For example, are overall environmental conditions safe in a wildlife habitat? So, this is a very complex question, right. There should be a definition of what is meant by the overall condition, what is the meant by the safety of a wild habitat, and this need to be known. So, virtual sensor can use reading of number of environmental conditions from physical sensor to compute safety level values and answer the query type of things, right. So, there is quite pervasive applications which can use this type of scenarios. And if we look at a layered sensor cloud architecture, so we have different wireless sensor providers, right, they provide data, information and type of things. We have a sensor centric middleware which is WSN maintenance, WSN registration type of things, and then we have a other middleware where which has a virtual sensors, emulating virtual sensor, provision management, image life cycle and so on and so forth, and then at the top interfaces. So, these are multiple layer, one is that physical underlying layer, over there want to have this WSN registration, WSN maintenance, data collection part, over there that virtualization layer, and then we have that physical user interface to connect to the things, and there we can have other type of things like user repository, data repository, session management, membership management and so on and so forth. So, there are variety of things which can be there. So, if we summarize, sensor cloud infrastructure virtualizes sensors and provides management mechanisms for virtualized sensors. Sensor cloud infrastructure enables end user to create virtual sensor group to dynamically by selecting the template of the virtual sensors or the sensor groups which are there. So, based on the user application I can select a particular template to work on that. Sensor cloud infrastructure focuses on sensor system management and sensor data management. So, this is more inclined or the vertical towards sensor data management and sensor system management, and aims at to take the burden deploying managing network away from the user, acting as a mediator between the user and the sensor network. So, there is a it is a sort of a connecting user applications with the deployed data or the sensing environment. So, as we have started today's discussion, that there is a omnipresent presence of different kind of sensors, starting from our mobile phones to different category of sensors, which is collecting huge volume of data, which could have been used for processing and supporting different user applications. So, that a virtualization mechanism is supported and evolving a sensor cloud which may help in addressing different real time applications or serving different real time applications with a variety of heterogeneous sensor collected or sensor acquired data system. Thank you.